Hi, so now we're going to focus on the processes that occur within fibrous repair, and I'm not going to go into very much detail, just to highlight the main processes. So we have to remember that initially, right at the beginning of everything, there was tissue injury. So what's going to happen directly as a result is hemostasis with the formation of fibrin, as well as, of course, inflammation, as shown here. And then after that, there will be granulation tissue that develops. So granulation tissue is completely different from granuloma, so please don't get them mixed up. And it is composed of angiogenesis, so small blood vessels that are newly formed, as well as fibroblast and myofibroblast proliferation. So these are some of the stromal cells that we will see in between the blood vessels in granulation tissue, and they play a role in healing and repair. The next step will be collagen synthesis. If you remember, part of fibrous repair, a very important part will be collagen, laying down of collagen, and also wound contraction. So wound contraction is brought about by the myofibroblasts, which have contractile features. They are able to pull the wound edges together and make the wound smaller. And finally, there is a process of remodeling to increase the strength of the wound. So here you see a microscopy picture showing you small blood vessels that all seem to be arranged in a parallel fashion. Actually, what we're looking at is granulation tissue in the skin. And in between these vessels, you see a lot of empty spaces. So this is due to edema, some small round cells here, which are chronic inflammatory cells, and some slightly more spindly cells here, which you will see later in higher power. These are the fibroblasts as well as the myofibroblasts. So that is granulation tissue. And as mentioned, in higher power, you can see that between these vascular structures, we can actually see some cells like these. So these spindle cells, they have central nuclei and very long feelers that are sent out in the cytoplasm. So these are myofibroblasts or fibroblasts, and the fibroblasts will eventually lay down the collagen. And myofibroblasts will help in wound contraction. So in regeneration as well as repair, none of this would be possible without several very important factors. One is the extracellular matrix, or ECM, and this is essentially three main types of macromolecules, and it includes structural proteins, which provide strength as well as some degree of recoil to the healing wound, and examples would be collagen and elastin. The second major type of molecule would be the adhesive glycoproteins. So these are the ones that are cell adhesion molecules, and they sort of form the glue that keeps everything together, that holds everything together, the extracellular matrix and the cellular components. And the third part of ECM would be the proteoglycans as well as hyaluronan. And these provide lubrication as well as resilience to the wound. And you can read up more about the specific components of these three major macromolecule types in your textbooks. So the second factor, of course, would be a lot of molecules, growth factors, cytokines, as well as enzymes that are released by cells. And of course, all these are produced by cells, which make the healing process possible. So what we have here would be the types of cells which are very important in healing, which release many of these factors, including macrophages, lymphocytes, fibroblasts, and endothelial cells, if you recall. Some important growth factors involved in healing would include platelet-derived growth factor, fibroblast growth factor, VEGF, vascular endothelial growth factor, and some important cytokines, which you may actually find familiar from your inflammation chapters, would be interleukin, interleukin 1, as well as TNF, or tumor necrosis factor. So do revise where these cytokines come from. Enzymes are also very important, such as matrix metalloproteinases, and these enzymes are important in the remodeling process, as well as also formation of granulation tissue and collagen synthesis. MMPs can come from neutrophils, from macrophages, and even from fibroblasts, as well as endothelial cells and even the epithelial cells that are located at the edges of the wound. And some of the functions include migration of cells, including epithelial cells, fibroblasts, endothelial cells across the extracellular matrix. They also play a very important role in wound contraction because they are secreted by myofibroblasts. And finally, in terms of remodeling, the MMPs help to remove the more disorganized components of the extracellular matrix in order that a more highly organized structure can supersede. Now, finally, to end off, how does the body actually decide whether to heal by regeneration or repair? Well, as mentioned before, one of the very important factors would be the tissue type that is located at the site of injury, whether it is labile versus permanent tissue. And the other important factor would be whether the extracellular matrix is breached. If the extracellular matrix for example, in epithelial tissues, this would be the basement membrane. If the basement membrane is intact, then the tissue would heal by regeneration. However, if the injury is a little bit more severe or deeper and the basement membrane is breached, then likely there will be some component of fibrosis, scarring, and repair as well. So here we just have a summary mind map showing you the healing process which occurs after tissue injury. And we've looked at two of the main processes: regeneration, which usually occurs in tissue types that are able to divide or enter the cell cycle, versus repair, which is healing where the tissue is patched up by laying down of collagen and extracellular matrix. We've looked at some of the main processes in fibrous repair, as well as the important components of both types of healing, the extracellular matrix, as well as these factors which are produced by cells, such as growth factors, cytokines, as well as enzymes. And you can revise on the specific factors that affect healing, which can be divided into local factors as well as systemic factors.